Hello, Algebra students. I hope everybody is doing well today. Today we are going to review solving quadratic equations. So last time you learned about graphing, or solving rather, with the quadratic formula. So we're going to review that today. We will also just briefly review all the different methods we have. So this right here in front of us is the note sheet that I will be going over. Again, you can print this if you want. It's up to you. Just if you want to have this to refer to, this is not what needs to be submitted. Remember, it is the practice assignment that needs to be submitted in Google Classroom. Okay, this is just for your reference. So at the top here, I have a summary of there are actually 4 different methods that we can use to solve a quadratic. So the first one we learned about last chapter was factoring. So I have the steps right here. Always when you're solving a quadratic, you want to start with 0 on one side. So what you're going to do is you might have to rearrange your equation so that you have 0 on one side. You're going to make a box in a diamond pattern to factor, right? Once you have your factors, you're going to set each factor equal to 0 and then solve for whatever the variable is. In most cases, it's an x. Sometimes it gets mixed up and they might use an n or a w or a y. Okay, those values are your solution. Okay, we'll review one of these in a minute. The next one is graphing. So last chapter you learned how to graph, and we talked about how whatever the solutions are when you solve by factoring, then those are your x-intercepts. So going the other way, if we found the x-intercepts of a graph, then those would be the solution. So you could rewrite your equation in either intercept form or graphing form, like we talked about last chapter. Once you find those x-intercepts and you have your graph, then the x-intercepts are your solutions. Remember last chapter we referred to them as roots or x-intercepts or solutions or zeros. Okay, they're all connected. We're not going to focus on this too much today because we did a lot of that last chapter. Okay, then completing the square. We talked about this also last chapter. We use this as a method of getting into vertex form. So we can also use that to solve an equation. So we get 0 on one side and do our generic rectangle to complete the square. The difference is instead of having like a y equals on the other side, you would just have a number. And once you get to that point, right, where you have a number equals to that quantity squared, then what you can do is take the square root of both sides, right, and then solve for that remaining variable. Remember, when you take the square root of both sides, it's a plus or minus on the other side, and then you have the 2 different equations to solve. Now, this process can get really tedious, especially when you have decimals or you have a number in front of the x squared term other than 1. So what mathematicians did is they generalized the process of completing the square on ax squared plus bx plus c, which we call our standard form. And when they completed the square on this general equation, they ended up with this formula here, which is called the quadratic formula. Now, factoring only works sometimes. Not everything is factoring. Completing this square can always work, but can kind of be a pain, like I said, when you have a coefficient other than 1 in front of the x squared, or if you have funky decimals and things like that. The beautiful thing about the quadratic formula is it always works no matter what, as long as your equation is quadratic. So again, we want to start by getting 0 on one side, so it's written in the standard form. From this form, we're going to figure out what our a, our b, and our c values are. A is always the number in front of the x squared term. B is always the number in front of the x term, and c is always the constant. Now, if you didn't have x's, and let's say you had n squared and you had n, the idea is the a is in front of the squared term, right? This is in front of the just first power term. This is in front of the constant. Okay, and then we'll substitute the ABC into our quadratic formula here. Simplify each expression. These are our solutions. Okay, so now these following equations can be solved using always the quadratic formula, but sometimes it is, if you feel really comfortable with factoring, you might want to try factoring first and see if it works. If you're like, I hated factoring, then you can always just use the quadratic formula. I do want to briefly review just the 3 methods, not the graphing this time, just so that you have all of those tools in your toolkit. Okay, so this first one, I would kind of think in my head, all right, do I think I could make a box and do a diamond pattern with this? And this one, it should work. So let's just review that process. And so the x squared term goes in the top left box, the 27, the constant goes in the bottom right. We're going to make our diamond pattern. So what goes on the other diagonal has to multiply to be whatever this diagonal multiplies to be. So x squared times 27. So 27x squared. It has to add to be our middle, which is 12x. So we want to think of some numbers that multiply to be 27x squared and add to be 12x. So you might try, 27x and 1x, but that doesn't add to 12x. Maybe you think 9x and 3x. Oh, that would add to be 12x. Okay, so those are my pair, and that's what's going to go on this diagonal. Okay, so here will be x plus 9, and this would be x plus 3. And so now this equation is going to turn into x plus 9 times x plus 3 equals 0. Okay, you're not done here. You're not done yet. You have to say what would make this side equal 0. And so to figure out what would make that side equal 0, now some of you might be able to just look at it and figure it out, or you can write an equation, well, two equations really, set each factor equal to 0 and solve. So here I would subtract 9 and subtract 9, so I'd have x is negative 9. And here I would subtract 3 and subtract 3, so I'd have x is negative 3. Those are my solutions. Okay. Now when I look at number 2, it's already in factored form. Sweet, I don't have to do anything. I'm already at the point where I could use the zero product property and set each factor equal to 0. Okay, so if it's in factored form, yay you, it's less work. Okay, so I have 3x equals negative 4, and then I divide by 3, and I get x equals negative 4/3. So those may or may not have been ones that you felt like you could figure out in your head, and if you can't, no worries, just set each of them equal to 0, and then divide, or solve, I'm sorry. We did have to divide though. Okay, so I've got my solutions. And so that's really that idea of the zero product property and the idea of factoring the box. Okay, so let's take a look at this next one. For this next one, I'm going to just show you how you could do it with completing the square. Now, the first thing I notice about this one, though, is it's not really in the right form. I really want to think of it as standard form. We have my x squared term, then I have my x term, and then I have my 5. Okay, and I still have that equals 0. And so when we completed the square, I know the x squared goes here, and I know these two here have to add up to be negative 2x, and they have to be the same. So the idea was that it was just basically half of that middle term, because those add up to be negative 2x. Okay, so if I were factoring, I could put an x here and here, and a negative 1 here, and a negative 1 here. And then when I multiply these, I end up getting 1. And then I look back over here, though, and that is not a 1. I need that to be a 1. So what do I need to do to both sides to turn that into a 1? I would have to subtract 4. Okay? And whatever I do to one side, I have to do to the other side. And so when we look at the steps here for completing the square, we drew our generic rectangle, we divided the x term in half and put that into both boxes. Then we figured out the final box. We added or subtracted some value to the original equation to make the ones tile equal to what appeared in the perfect square. So we subtracted 4 to make that happen. And then here, this is what we just did. We added or subtracted that same value to the other side of the equation. Okay, so now we're at this point. Solve the resulting equation by taking the square root of both sides. Okay, so now let's do that part. So let's see what we have left here. So I have x squared minus 2x plus 1 equals negative 4. And then here, this would be x minus 1 squared equals negative 4. And then I would take the square root of both sides. So let's go ahead and do this. So if I take the square root of both sides, I'm left with x minus 1 equals plus or minus the square root of negative 4. All right, you should be looking at that and saying, wait a second, that doesn't make sense. I can't take the square root of a negative number. And you're right, you can't. So this one actually has no solutions because you can't take the square root of a negative number. Now, that's going to happen sometimes where you're going to come up against something that's no solutions. What that would have meant is if we had tried to factor this, that also wouldn't have been factorable. Okay, just as an aside, I just want to show you if this hadn't been a negative 4. Okay, so this is kind of like a bonus example here. Let's say we had not ended up with a -4 there, and let's say I had gotten to this point here. I just want to show you how you would have finished it if you could have solved it and taken the square root of both sides. So this is kind of, we're done with this one, but if I had used that idea of I take the square root of both sides and I get x minus 1 equals, now this I can take the square root of, it's 2, okay? And I had a note here, make sure you include the plus or minus when you take the square root, and now we have two equations left to solve. So here I would have to solve x minus 1 equals 2, and x minus 1 equals -2. So this would be 3, and this would be -1, okay? Now that's not the solution for this again. Remember, that one had no solutions, and that is going to happen sometimes. Okay, but that's how you could solve if it were a completing the square that would work. All right, so now the next one, number 4. Before I even start that, again, I notice it's not in the right form. I need to have it in that ax squared plus bx plus c form. So I need everything to one side and 0 on the other. It really does not matter which side you get everything on. It could be the left or it could be the right. Just what's the easiest way to get everything onto one side. So I'm going to subtract the 2x and I'm going to subtract the 45. The 45 over here. Okay, so I have 20x squared minus 32x minus 45 equals 0. All right, so now when I look at this, I mean, I could try to factor it if I wanted to, but I'm just thinking about that box I would have to make, and I'd have to multiply 20 by -45 if I made the box for the diamond pattern. I'm just thinking that there's a lot of factors there. I don't even want to try it. It wouldn't be quick and easy. If I wanted to complete the square, I'd have to divide everything by 20 because you can't have a number in front when you are doing completing the square. Okay, so that means best bet is the quadratic formula. So remember, the next thing I want to do is I want to identify the a, the b, and the c. The a is always in front of the square term. The b is always in front of the x term, and because it was subtraction, I need to think of it as -32. And the c is always the constant. Again, it's subtraction. I have to think of it as -45. Okay, so now I'm going to substitute into our quadratic formula. I'm just going to rewrite that here so we have it right in front of us to refer to. If we were in class, you would all be asking, do we have to memorize that? And I would say, you really should, because I pre-calc kids right now that are like, wait, what's the quadratic formula? And they need to have it memorized. So just might as well put it in your brain. Okay, so the opposite of b. So here's my b value, the opposite. So that means if it's positive, the opposite is negative. If it's negative, the opposite is positive. So the opposite of a -32 would be 32, plus or minus the square root of -32 squared. Notice I'm putting that -2 in parentheses because I want it to be like -32 times -32, which I want it to be positive. If you don't put the negative in parentheses, it's going to give you a negative answer. So -4 times our a value is 20, times our c value is -45. The whole thing is over 2 times the a value. Okay, so if I just went too fast, pause, re-listen to it. Make sure you really understand where every single part of that came from. It's really important to understand where it came from because now we need to simplify it. Okay, and notice I said the whole thing is over 2 times a, not just the square root part, not just the 32, the whole thing. Okay, so I have x equals 32 plus or minus the square root of, okay, I like to do it one thing at a time. The calculator does not have, there's not a way to put the plus or minus in at one time, all, is a step. So you kind of need to take it a little bit by steps, but I'm going to use the calculator to help me a bit. So I'm going to use the calculator to figure that out. If you don't have a scientific calculator, Decimals has a scientific calculator. You can do it also in the graphing screen, but the scientific calculator, you don't have to worry about the graphing part. So if you just Google Decimal Scientific Calculator, this is what will pop up. And so I want to do that, what was inside under my radical. So it was -32, so I pick my parentheses over here, and I'm thinking I have to use this for my negative sign, the subtraction sign, which I don't exactly love, but that's how it works. Then I have to bump out, and I want that squared, minus 4 times my a value, which was 20. So 20. And then times my c value, which was -45. Then hit this guy down here, and it gives you the answer, 4,624. Okay, so let me just jot that down. So 4,624 all over 2 times 20. I can figure that one out. That's 40. So I have negative 32 plus or minus. Okay, so now the square root. So here's my square root of my answer. I could just click this button here. Do you see where it says answer? And it will bring it down and tell me it's 68. Or you could type the number. Either way. Okay, so I'm going to jot that down. So you can see I put 68. Now I've taken the square root. Once you take the square root, you don't have the square root symbol anymore. Okay, so I know people are confused sometimes about, well, with plus or minus, what does that mean? Well, remember over here, we had the positive or negative and we got the two different answers. That's where this is coming from. So I have 32 plus 68 divided by 40. I have to figure out what that is. And then 32 minus 68 divided by 40. That's kind of what was happening with this step here with the 2 and the negative 2, and then I had to solve both of them. That's where that came from if we would have completed the square on the standard form. Okay, so I'm going to go back to my calculator here, and there we go. You can just hit, if you want, you could just hit the divide key right now, and then on top you can just type 32 plus 68. You want that whole thing on top, not just the 68, and then that was over what, 40? And it tells me my answer is 2.5. And look fancy, you could click on the fraction if you wanted it to be a fraction. Okay, so 2.5, I'm going to jot that down. All right, and then for the next one, it was 32 minus 68. Now up here, I could just go in to my previous step and just type minus, and then it changes it to the negative 0.09. So I could do it like that, or I could have just come to another step, another calculation, and then hit the divide and then done it that way. Okay, so then those are my two answers, 2.5 and negative 0.9. All right, so we're going to do a couple more. So I would recommend for this next one, pausing and then follow through with the steps that we had on the previous page, right? So you're going to get 0 on one side, make sure it's in this form, figure out your A, B, and C, substitute those into the quadratic formula, simplify both expressions. If you have not written that quadratic formula somewhere in bold that you're going to refer to over and over again, you really should. Okay, so hit pause, do this problem. Okay, so if I were starting this problem, I would first move over that 6 by subtracting it, and then I would identify my A, and my B, and my C. There they are. And then I would plug into my quadratic formula. So I would have x equals the opposite of b, so negative 9, plus or minus the square root of b squared, so 9 squared, minus 4 times a times c, the whole thing over 2 times a. Now somebody might be thinking, wait, she didn't put that b in parentheses before she squared it. And I didn't this time because it's positive, but it's not a bad habit to just always put it in parentheses so you don't forget to put it in parentheses when you really need to. So in that last one, if you hadn't put that negative 32 in parentheses before you squared it, you would get an answer. You would get like no solutions. You'd get that it didn't work, and it did. Okay, so we have negative 9 plus or minus the square root of, again, I like to just put in what's under the radical before I do the square root, because sometimes you might get some sort of error and you might not be sure why you're getting the error if you put the whole square root in all together. So that's how I like to do it. Okay, I'm going to hit clear all so I don't have all that extra junk. No, everything clear all. Goodbye. Okay, so what are we entering? 9 squared, and again, if you like, you can put that 9 in parentheses, bump out before you square it. If you don't bump out before you square it, then you might as well have not done the parentheses at all. Minus 4 times my a value, which was 0.5, times my c value, which was negative 8.8. And I get 98.6. Okay, so I'm going to put that underneath my radical. Okay, let's switch back. So I put that 98.6. Everybody's regular temperature, right? That's supposed to be your temperature if you're healthy. And then 2 times a half is 1. Oh, this is kind of easy because dividing by 1 just stays the same. All right, and then let's take the square root of that 98.6. So I'm going to do square root of my answer. And I get 9. This one is not nice, right? It just keeps going. Usually these we're going to round to the nearest hundredth. That's 2 places after the decimal. So 9.92. I see a 9 after the 2. We're going to bump the 2 to a 3. Okay, so 9.93. So I have x equals -9 plus or minus 9.93 over 1. See, in this case, I don't really need to write the over 1 because anything divided by 1 is just 1. Okay, so then I have x equals -9 plus 9.93, and then x equals -9 minus 9.93. I don't even need the calculator. Okay, so this is going to just be 0.93, and this is going to be -18.93. And those are our two solutions. Okay, one more for fun. If you feel like you've got this, then go ahead and just start on the assignment, but I'm going to do one more just to make sure we all have it. Okay. So I'm going to rearrange this. Well, I have it equals 0, so that's good. I don't have to move anything over, but I do want the squared term first and the constant term second, and then the -5 at the end. Okay, so my A is 0.2, my B is 3.2, my C is -5. And then I'm going to substitute in to my formula. So the opposite of B, this is positive, so this would be -3.2 plus or minus the square root of 3.2 squared minus 4 times A times C. The whole thing is over 2 times A, which is 0.2. All right, so I have -3.2 plus or minus the square root of, and I'm going to put this into my calculator to see what I get. All right, so square root of 3.2 squared. So 3.2, I'm gonna bump out, I'm gonna square it, minus 4 times, what was that, 0.2 times -5. I don't like how you have to hit the subtraction key for negatives because we never usually do that. We have a separate button, but this one doesn't. Okay, so what is it? 3.77 is what, oh, I put the whole square root in. I didn't mean to do that. Okay, the whole square root is going to come out to be 3.77. If I had just put in the 3.2 squared, and let me do that just quickly so that you can see, I did what I said I wouldn't normally do by accident. But we should get the same thing, right? Okay. Times -5. Okay, so I get 1424, and then when I do the square root of my answer, I get 3.77. Okay, so I'm going to jot down that step. You don't necessarily need it, didn't need it in this case. On the bottom, I have the 2 times the 0.2. So 2 times 0.2, oops, not 2 points, that's not going to work. 0.2, which is, what did I just do? Good grief. Let's take that from the top. 0.2 times 2, which is 0.4, which I knew that anyway. All right, so let's go back. So we had said that the square root of the 14.24 was 3.77. And then down here I have the 0.4. Okay, and then here's where I'm going to split it. So I'm going to have -3.2 plus 3.77 divided by 0.4 and -3.2 minus 3.77 divided by 0.4. Okay, so I'm going to go back to my calculator and see what those are, because I don't know what those are off the top of my head. Okay, so I'm going to hit my fraction bar and then type in. So I've got -3.2 plus 3.77, and then over, what was it, 0.4. And I get, I'm going to jot this down, 1.425. Okay, then I can just go up here and change it to subtraction, and the other solution is -17.425. If you ever want to check your work, you could always, you can always plug your answers in to your original problem and see if they make the left side equal 0. You could also graph the original equation and see if those are your x-intercepts, and that's a nice way to check your work without, having to plug in and go through all the arithmetic. Okay, I hope everybody is having a great day and taking care of themselves.